Howdy, PreCal, it's Miss Kosh. I have a break in my tutoring schedule and I want to try and finish the multiple choice questions that Mr. Passwater wrote from Unit 3. So we'll see how many I can get done today, because if I don't do it today, I don't know when it's going to happen. All right, so on this one, we see 4 cardioids and we're given an equation. So the first thing I recognize is that with cosine right here, when I plug in 0, cosine of 0 is 1. So f of 0 had better equal 3, because it's 1.5 plus 1.5. And so the only one of these at an angle of 0 that has a radius of 3 is this one right here. So that was, I would argue, a pretty easy way to solve that problem. Okay, the next one. So here's what we know. It's when we see, it's a rose, when we see 4 theta right here, that tells us there's going to be 8 petals. So we can immediately get rid of those that only have 2 petals. And now sine of 0 is 0. So we're not going to have anything on where theta equals 0. So right here, theta equals 0, we're out here at 3, which is no good. This would be the cosine equation. So it's that one. Okay, 6 cosine of 2 theta, this is going to have 4 petals, so we can eliminate these that have more than 4 petals. And cosine means that, just like we said a second ago, we have something at theta equals 0. So, and it should be 6, and it is, and there we go. This one would be the sine version. Oh, fun. Okay, so on this one, when we have sine squared, what that means is that we're going to be able to, we're going to have 2 individual circles, because you can plug in different values, and when you square them, you'll get something positive. So here's what, let me show you what I'm talking about. Like if I say r is equal to 6 sine of theta, when I go to graph this, plug in 0, I'm at 0. This becomes a circle. Plug in pi over 2, sine of pi over 2 is 1. So 1 times 6 is 6. And so it does this circle that sits kind of up here like that. And we can do that whole process. If we just go from 0 to pi, we've done the whole thing. When I go again, when I keep going beyond pi, so say when I want, let's call this f of theta. If I want, let's see, f of 3 pi over 2. If I'm at f of 3 pi over 2, sine of 3 pi over 2 is equal to -1, so this becomes -6. Well, instead of going 3 pi over 2 and going down, we have to turn around and we end up right back here where we started. So this does a complete loop. Like if I restricted the domain of this one to, I guess we would call that the domain. If I restrict the inputs to just the theta goes from 0 to pi, we've got the whole circle. Okay, but when I start to square this, now when I, like, if I had this squared, I still have this part that looks something roughly, it might be a little more elongated, it may not be exactly circular, but when I get to those negative values, let's see what happens when I have 3 pi over 2. I have 6 times sine of 3 pi over 2. This whole thing gets squared. Well, sine of 3 pi over 2 is -1. I square -1 and I get +1 and I'm 6. So that's going to come down here. Okay, it's not exactly circular like we said, but it's going to look something more like this one right here. Okay? These would have rotations, and you'd have to add, I don't know. They're pretty. Okay, we did that side. Fantastic. Let's see. Here, I need something. Oh, this is a rose. It's got 3 petals, and it's going to have something on theta equals 0. So it's going to have 3 petals. I see 3 petals, 3 petals, 3 petals. They all have 3 petals, so we can't eliminate with that. Well, they're just making sure you know that it's right here at 0. At theta equals 0, you have an r value of 3. Okay. Oh, more. Okay. Let's see if I plug in. Notice once again, I have all of my, well, not all of them, but if I plug in 0, I'm going to have either a 6 or 0, or is that probably something between, something near 3? Maybe it's 3, and then 3. Okay, so if we get 3, we'll have to decide between one of these. Okay, f of 0 would be 3 minus 0 is just 3. Okay, so that narrowed it down, that eliminated those two, narrowed it down to one of these. Notice I wasn't even paying attention to the fact that cosine, of course, is on the x-axis. I was just working off, if I forget all the things that I was supposed to have memorized, then what happens? Okay, so let's plug in pi over 2. And I have 3 minus pi over 2 is, sine of pi over 2 is 1. So 3 minus 3 is equal to 0. So at pi over 2, okay, it's kind of helpful, but let's make sure, because they're both of these have, if I'm looking at the graph, pi over 2 is coming this way. And so I want to see pi over 2, I have a point here at 0, and I have a point here at 0, but I also have one, this is, at pi over 2, this would be a radius of 6, but it could be a radius of negative 6 if, my brain just stopped, if the theta value is 3 pi over 2. So let's check. Like that alone is not enough for me to definitively say which is which, and I have forgotten all my rules. So f of, let's look at 3 pi over 2 is going to be equal to 3 minus 3 times sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. Multiply it by another negative, and this is 6. So what's going to happen is at 3 pi over 2, we equal negative 6. We're coming down here, and that's that point. So this is the one we want. Fantastic. We already did that side. Ooh, there's even more. Okay, I think this has an inner loop. The question is which one? I forget. I always have to, when I'm in the middle of teaching it and grading and all that kind of stuff, then I remember all my little details. But I have stepped away and done a lot of other math since then. So we can always plug in values and check and see what's happening. So what would make sense to plug in? F of 0 is 1. Okay, so 0, that is not 1. This is 1. Okay, this is 1. And this has 1. So we've eliminated one possibility. That's not an option, but we need more information. Okay, so let's see. Is this? Let's plug in pi over 2 and 3 pi over 2. So f of pi over 2. This is 1 minus 2. So this is negative 1. So this would be that point. That's fine. Pi over 2 negative 1. It does not show up here. Okay, so there goes that possibility. This one at pi over 2, we came down to, I think this might be at 1, pi over 2 was going this way, but we turned around and went negative, and so that one was that right there. So we still have two possibilities. Let's look at 3 pi over 2. Okay, f of 3 pi over 2, sine of 3 pi over 2 is negative 1 times negative 2 is positive 2 plus 1 is 3. So looking at this one, 3 pi over 2 would be coming down this way. I don't have anything out here at 3, so that eliminates that one. And we do have something at 3 right here. So this is the one. Now, is this the best way to do this problem? Maybe not, but if you forget all the intricacies about, oh, this is a Limacon with an inner loop, and if this plus this is true, and that, well, sometimes I forget those details. So if you memorize them, then you might go faster, but I'm pretty confident that I got the right answer right there. All right, here we go. Okay, so this is a rose with 4 petals, as we see above. They're restricting the domain from 5 pi over 4 to 3 pi over 2. Okay, let's see what happens when I plug in 3 pi over 2. I get 6 cosine of 3 pi over 2 times 2 is 3, so 3 pi, where is 3 pi? It's over here. The cosine value is negative 1, so this is negative 6. So at 3 pi over 2, I'm going to come negative 6. So I'm here at B is where I'm ending up. Okay, I didn't read the whole question. Maybe I should do that. The domain of f is restricted to this. Which of the following describes the portion of the graph that remains? Okay. Well, we want at 3 pi over 6 to go, I lied. What am I saying? At 3 pi over 2, we want a radius of 6. Oh, of negative 6. So I'm up here at B. So this becomes f of 3 pi over 2. I don't know what I was about to write. Let's see, 5 pi over 4. So f of 5 pi over 4 would be equal to 6 times cosine of 2 times that is going to be 5 pi over 2. Where is 5 pi over 2? We have 1 pi over 2, 2 pi over 2, 3, 4, 5 pi over 2. This cosine value is 0. So at 5 pi over 4, we're at 0. So what I think is happening is we do half a pedal per pi over 4. So it's 0 to 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Here we get to 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and then we're back to 8 pi over 4. And that's kind of the process of how we do this. So the piece that we care about is this piece right through here, which is in quadrant 1 from E to B. I think there's a typo. Yeah, I think this should be quadrant 1. If I'm wrong, or if I'm right, and you saw this in a different, if you have the updated version of his practice, let me know, because it started here. Let me just think through it one more time, because I hate to. A to E would be this in quadrant 3. E to D in quadrant, that's quadrant 3. D to E. E to B. E to B, it doesn't move this direction. Okay, let me make sure. We're starting here, we go this way, we come around, we come that way. Yeah, I'm pretty sure that should say quadrant 1. If you know that he had a typo and has since fixed it, you can comment below and tell me that, yes, Ms. Kosh, you were right. Okay, if I'm wrong, you can tell me that too, but just say it nicely. All right, last one for this video. This is another, it's very similar to that last one, except it's not, this one is sitting here on the x-axis like that. This one is not, because sine of, I mean, I feel like I've said this a few times already in this video. Okay, so 7 pi over 4 to 2 pi. This one is going to start here. This is 1 pi over 4. Here's 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. 7 pi over 4 gets us here. And then we'll come back to 8 pi over 4 by, so it's going to be from A to E. A to E in the bottom, I think it's this guy. So that's just knowing how these things move. But let's double check by plugging in f of 7 pi over 4 would be 2 times, so 6 sine of 7 pi over 2. Where is 7 pi over 2? 1, 2, 3, 4, 5, 6. 7 pi over 2 is down here, so that sine value is -1. So this is -6. So 7 pi over 4, where would 7 pi over 4 be? Here, this way, but we had to turn around and come back this way at -6. So this is that point, and then we are going to get back to the pole. So I feel pretty comfortable with that answer. Hopefully that made sense, and you can answer these sorts of questions. Ooh, the next one is rates of change in polar functions. Come back for the next video, and I will see you there. All right, like, subscribe, comment, say nice things, all of the above. Go home and practice.